Good morning, all of you. Are you able to hear me? Okay. Fine. What is the last thing I've done? I had asked you all to do exercise 1 if I'm not wrong. Have you all finished? Okay. Or did I do metamerism also? Metamerism is completed, no? Okay, C5H10O2, carboxylic acid and ester. Fine, I'll do that first and then we'll see the exercise 1 and then I'll proceed with automerism. Okay, otherwise I'll do what? I'll complete structural and then I will take the exercise 1. That makes more sense. Okay, now C5, H10, O2. How many isomers did you all get here? Yeah, that's what it's better I do tautomerism and then I go back to, then I do the exercise 1. You'll get these carboxylic acids. Did you all get 4 carboxylic acids? And these are the esters which you'll get. So in all 13 isomers. Did you all get these 13? Okay, only 9 you got. What about the others? Okay, copy these. Then we'll just discuss which type of isomerism. And then I'll move on to tautomerism. Did you all finish writing? Okay, write it. Disha, I teach in Andheri, Dadar and Borivali. Okay, I will complete it now. Fine. So let us discuss the answers for this. Pranav, esters are from 5 to 13. पहले 4 कार्बोक्सिलिक एसिड्स हैं और 5 to 13 सारे एस्टर्स हैं. ठीक है. Okay, first and second, what is the relation between structure 1 and structure 2? What type of isomers? Yes, they are chain isomers. Very good. Carbon chain का arrangement अलग है parent chain. Okay. 1 and 2 are chain isomers. What about 1 and 3? 1 and 3 are also chain. Yes. 1 and 4? 1 and 4 are also chain. Correct. 1 and 5? Functional. Very good. Yes. 1 and 5 are functional. 1 and 6 is functional. This goes on till now 1 and 13. Fine. Okay. 2 and 3. 2 and 3 position isomers. 2 and 4. Yes, 2 and 4 are chain isomers. 2 and 5 will be functional till 13. Correct? 3 and 4. Yes, 3 and 4 are chain isomers. Correct. 3 and 5 will be functional till 3 and 13. Now it's functional. 4 and 5. Functional. Correct. You can write C for chain. You can write M for metamerism. You can write F for functional. And you can write P for position. करेक्ट. 4 और 5 फंक्शनल है till 13. Okay. 5 and 6. Yes, 5 and 6 are chain isomers. 5 and 7. Yes, very good. 5 and 7 are metamers. 5 and 8. 5 and 8. Yes, they are also metamers. 5 and 9. अभिमन्यु 5 and 8 are metamers बच्चा. ये देखो 5 में ये C के साथ प्रोपाइल ग्रुप है और O के साथ मिथाइल है. और 8 में देखो C के साथ मिथाइल है और O के साथ प्रोपाइल है. तो अल्काइल ग्रुप्स अलग अलग हैं. So they are metamers. Fine. Okay. 5 and 9. No, 5 and 9 are also metamers only. ना? C के साथ मिथाइल है और इसके साथ आइसोप्रोपाइल है. So they are metamers. Okay. 5 and 9 are metamers. What about 5 and 10? In fact, सारे metamers ही हैं. 5 and 10, 5 and 11, 5 and 12, 5 and 13 are all metamers. ठीक है? 6 and 7. 6 and 7 are also metamers. Yes. 6 and 8. Yes, these are also metamers. 6 and 9 is also metamers. 6 and 10 is also metamerism. 6 and 11 also, 6 and 12 also, 6 and 13 also. 7 and 8. Yes. हाँ, सारे metamers ही हैं. Okay. So I think this you all have understood. Now I'll proceed to tautomerism. So give the heading as tautomerism. Just write down about this, then I will explain what this is. Tautomerism is a special kind of functional group isomerism. Tautomerism is a special kind of functional group isomerism in which tautomerism is a special kind of functional group isomerism in which two compounds with different functional groups show spontaneous interconversion and they coexist under conditions of dynamic equilibrium. I am repeating what I have said. Tautomerism is a special kind of functional group isomerism in which two compounds with different functional groups show spontaneous interconversion and they coexist under conditions of dynamic equilibrium. Lakshmi, you want me to repeat once more?
Yes, ma'am.
Okay. Tautomerism is a special kind of functional group isomerism in which two compounds with different functional groups show spontaneous interconversion and they coexist under conditions of dynamic equilibrium. See, Disha is given the definition on the chat in the chat box. Okay, so now just let me explain what I have said. Functional group isomerism we have already done. Say for example, if I take this compound and if I take this compound, what is the relation between these two? Can I say they are isomers because they have the same molecular formula, that is C2H6O. Both are having the same molecular formula C2H6O, but they differ in what? They differ in the functional
groups.
Yes, they differ in the functional group. This is an alcohol and this is an ether. So these form a pair of functional group isomers. Now alcohols and ethers are functionally isomeric. But can an alcohol on its own, spontaneously, means on its own, change into ether? Alcohol, ethyl alcohol agar main le rahi hu, you know, this is the alcohol which we drink. For drinking purposes, जो alcohol use होता है वो ये होता है ethyl alcohol. Can ethyl alcohol on its own change into ether? That is not possible. Neither can an ether on its own change into an alcohol. If an alcohol has to change into ether, you have to bring about a chemical reaction. Similarly, if an ether has to be converted into an alcohol, that will be only via a chemical reaction. So, conversion of alcohol to ether and ether to alcohol is not possible. On its own, it will never occur. It can occur only via a chemical reaction. But in tautomerism, what happens is there are two compounds with two different functional groups and they convert into each other on their own. You know what is the meaning of spontaneous? What do you mean by
In
spontaneous?
an instant.
No, spontaneous is not instantaneous. Yes, spontaneous is basically naturally occurring processes. Processes which occur in nature on their own are classified as spontaneous processes. जो fast processes होते हैं उनको spontaneous नहीं बोलते हैं, उनको instantaneous बोलते हैं. Okay, so a process which happens on its own or a process which occurs in nature on its own is called as a spontaneous process. Fine. Could you give me some examples of spontaneous processes? Yes, radiation. Radiation is a spontaneous process. Photosynthesis, very good. Rusting of iron. Can I say rusting of iron is spontaneous? Yes, drying of leaves is spontaneous. Water flowing down a hill is spontaneous. Am I right? Yes, ozone, formation of ozone layer is again spontaneous. Formation of clouds is spontaneous. Have you seen water climbing up a hill on its own? That is non-spontaneous. Correct? Natural disintegration of uranium to lead, that is spontaneous again. Fine. So spontaneous processes are those which happen in nature on their own. Like sodium. Sodium, if I just leave it open to air, sodium will violently react with air. So in order to prevent this spontaneous reaction between sodium and air, we know we store sodium under kerosene, correct? So there are many processes which occur in nature on their own. And all those processes are known as spontaneous processes. जो fast processes होते हैं उनको spontaneous नहीं बोलते, उनको instantaneous बोलते हैं. Okay, fine. So in short, processes which happen on their own are called as spontaneous processes. What do you understand by the term equilibrium? What do you mean by equilibrium? Yes, equilibrium stage pe both reactants and products do coexist. Correct. Equilibrium is a state in a reversible process. It's a state in a reversible process where the rates of forward and the rates of backward reaction are equal. I repeat, equilibrium is a state in a chemical reaction where the rate of forward and the rate of backward reaction are equal. Okay, that means forward reaction and backward reactions are occurring at the same rate. The process has to be reversible, of course. So equilibrium can be attained only in a reversible process. It's a state in which the rate of forward and backward reactions are equal. Fine. Okay. What do you mean by the term dynamic equilibrium? Dynamic means what? Yes, dynamic means in motion. Correct. Dynamic means continuous activity. The term dynamic means continuous activity. Or we can say it is in motion. Could you give me an example of dynamic equilibrium if you know? Yes, that is a chemical process. Formation of ammonia. Yes, depletion of ozone and so on. इसमें क्या होता है? Once equilibrium is reached, the rates of conversion of nitrogen and hydrogen to ammonia becomes equal to the rate of decomposition of ammonia into nitrogen and hydrogen. The reaction continuously takes place even when equilibrium has been attained. But it appears to us that the reaction has come to an end. And why it appears that reaction has come to an end? Because the rate at which the reactants are giving me the product is same as the rate at which the product is decomposing back to reactants. That means the amount of product and reactant will not change with time. And if the amount of product and reactant is not going to change with time, it will be appearing to us that the reaction has come to an end. But actually it is not that case because the reaction does occur at the molecular level. Ammonia is being formed still and simultaneously ammonia is being decomposed at the same rate. Okay, so continuous activity is there. I could give you an example of physical equilibrium as well. Say for example, you have a tank. ये उसका outlet है और ये उसका inlet है tank का. Initially I fill the tank till this level with water. So this is the level of water I am filling in. The outlets and inlets are now closed. So the level of water will not change. It will remain here. Now what do? Is I open this inlet and I also open the outlet and I allow the water to come in this tank at the same rate at which the water is leaving the tank. What will happen to the level of water? Yes, the level of water will not change. And if the level of water is not changing, the process I say is in dynamic equilibrium. Okay, The process is occurring. Water is coming in. Water is leaving the tank. But since the rate of water coming in and the rate of water leaving out is the same, and hence the level of water will not change. So this you can say is dynamic equilibrium. Then even if you have visited, of course you all must have visited malls. You know, escalator hota hai wahan par. Escalators are the stairs which take you up and bring you down the different floors. Okay. So if you consider a boy trying to climb up an escalator, which is trying to, and that escalator is trying to bring the boy down. And if both are occurring at the same rate, what would you actually observe? Escalator is trying to move the boy down, and the boy is trying to climb up the escalator. Yes, you will find that the boy is actually running at the same place. The position of the boy will not change. So that is also an example of dynamic equilibrium. Okay. So dynamic means continuous motion hota hai, but it appears that nothing is happening because the rates at which the forward and the backward processes occur are the same. Yes, this is also what happens on a treadmill. Yes. Yes, Lakshmi, very good. Treadmill पे भी वही होता है. Treadmill पे जो speed at which the person runs on a treadmill and the speed at which the belt moves on the treadmill, those speeds are same. That is why it appears that you are running at the same position. Fine. It should not be like you running at a faster rate or the belt moving at a faster rate. If that happens, then the person will definitely fall down the treadmill. Okay. So again, that is an example of dynamic equilibrium. So dynamic equilibrium means continuous motion is there, but the rates of forward and the backward processes have become equal. Fine. Now tautomerism, as I said, is a special kind of functional group isomerism in which two compounds with different functional groups. Say, for example, I take this compound. What functional group is there in this compound? Can I say ketone hai isme? Yes, this has a ketonic functional group, also known as the keto group. Basically, C double bond O is known as a keto group or carbonyl group भी बोलते हैं इसको. And what functional group is there in this compound? Yes, this has an alcoholic group. But can I say the alcoholic group is present on a carbon having double bond? Alcoholic group if present on a carbon having double bond, then the functional group is called as an enol. Why do they call it as enol? Because en matlab carbon carbon double bond or all matlab alcohol. If the alcohol lies on the carbon having double bond, then the compound is called as enol. Even this compound is known as phenol. You all know this. इसको phenol बोलते हैं ना? Sorry. Enol. It's an enol, okay? Because the OH group is directly bonded to a carbon having double bond. Now these two compounds, can I say they have the same molecular formula? Both are C3H6O. Molecular formula same, but they have different functional groups. Now what is so special about this? In tautomerism, it is observed that this ketone form and this enol form, they are interconvertible. Interconvertible means a keto spontaneously changes into enol. Spontaneously means on its own. It changes into enol. And enol also spontaneously changes back into the keto form. Both of them, they exist together. That means if you take a sample of acetone, that acetone sample will change on its own to this form. And this form can change back into the acetone, that is the ketone form. This process is spontaneous. The conversion of keto to enol and enol back to keto, it is a spontaneous process. And these two different functional groups, they coexist together under conditions of dynamic equilibrium. That means once equilibrium has been attained between these two forms, the rate at which the keto will change into enol becomes same as the rate at which enol changes back into keto form. Yes, Disha, this reaction occurs. It is always going to occur. Okay, all the time. Yes, all the time the keto will change into enol and enol changes back into keto. And these substances, the keto and the enol form, they coexist together under conditions of dynamic equilibrium. So this is a special type of functional group isomerism in which two compounds with different functional groups show spontaneous interconversion and they coexist together in conditions of dynamic equilibrium. There are very few examples for tautomerism. One example which I've given you is keto-enol tautomerism. Okay. I'll be doing all the examples where keto-enol tautomerism occurs. Okay, why would this happen? That is a good question. Tautomerism occurs due to the acidic nature of the alpha hydrogen. It occurs due to the acidic nature of the alpha hydrogen. Now, what do I mean by this? I'll just explain it. Do you know what is an alpha carbon? The carbon joined to the carbon joined to the functional group is the alpha carbon. Okay. The carbon joined to the functional group is the alpha carbon. Now, this is the functional group. These are the carbon atoms joined to the functional group. So these are your alpha carbon. I repeat, the carbon joined to the functional group is the alpha carbon. Now this is the functional group, the ketonic group. The carbon atoms joined to the ketone are the alpha carbon. So both these carbon atoms are alpha carbon. All the hydrogen atoms present on these are all alpha hydrogen. So this molecule has 6 alpha hydrogen, 3 here and 3 here. Now these alpha hydrogen are acidic in nature. Why are these alpha hydrogen acidic? Because if I remove this hydrogen as H plus, what charge will carbon get?
Minus.
Yes. That negatively charged carbon, can I say it is resonance stabilized? There'll be resonance stabilization here. That makes the alpha hydrogen acidic. Acidic means this can come out as H plus. As this electron pair comes out as H plus, this negatively charged, the electron pair here, it shifts here to form a double bond. But can this carbon form 5 bonds? No. So as this electron pair shifts in here, this pi bond simultaneously shifts on to oxygen. Oxygen develops a negative charge. This H plus which has come out from here, that now migrates to the negatively charged oxygen, giving you the enol form. I repeat what I said. The hydrogen here is acidic in nature. This can easily come out as H plus. As the H plus comes out, the electron pair between this carbon and hydrogen, that electron pair simultaneously shifts here between carbon and carbon to form a double bond. But this carbon cannot form 5 bonds. So as this electron pair is shifting here to form a double bond, simultaneously that causes this pi bond to shift over to oxygen atom, due to which the oxygen develops a negative charge. So this H plus which has come out, that H plus migrates to the negatively charged oxygen, giving you the enol form. But here also, the hydrogen here is acidic. So this again can come out as H plus ions. As the H plus ions comes out, this electron pair again shifts back to form a double bond between carbon and oxygen. Again, this carbon cannot form 5 bonds. So as this electron pair shifts in here to form a double bond here, simultaneously this electron pair shifts on to carbon, creating a negative charge on carbon. And this H plus now migrates to that negatively charged carbon, giving you back the keto form. So this keeps on happening. The hydrogen here comes out as H plus, migrates to oxygen. Again, from oxygen, that hydrogen comes out as H plus and migrates to carbon. So it is nothing but the migration of H plus ions from carbon to oxygen and vice versa. Hence, this process is also known as prototropy. Prototropy means migration of H plus ions. It is also known as cationotropy. Sorry, because it is the migration of a cation. Okay, H plus is a cation. So migration of a cation here is, therefore it is also called as cationotropy, or it can be also called as prototropy. So for tautomerism, you can also use the terms prototropy and cationotropy. It represents the same thing. So basically, tautomerism occurs due to the acidic nature of the alpha hydrogen. The alpha hydrogen comes out as H plus very easily. It migrates to oxygen. Again, oxygen also, it is not stable over there. So again, it comes out from there as H plus and migrates back to carbon. So this keeps on happening in the molecule, and soon they attain dynamic equilibrium. Dynamic equilibrium jab attain hoga, the rate at which the ketone changes into enol becomes same as the rate at which the enol changes back into the keto form. Did you understand the mechanism of tautomerism? कैसे होता है? Okay. Just write down this example, then I'll give you some more.
मैम वो अल्फा हाइड्रोजन राइट साइड से भी जा सकता है ना?
हाँ, राइट साइड से भी जाएगा तो भी सेम इनॉल बनेगा ना. इनॉल आप ऐसे लिखो, or you can also write the enol like this. Can I say both are same? These alpha hydrogen can also participate. Okay. In fact, all the 6 alpha hydrogen can participate, but at a time only one will participate. Did you all finish writing all this?
Yes, ma'am. Yes, ma'am.
Okay. So I'm giving you some compounds, just write down their enol forms. Sat tautomerism is observed only for certain molecules. Okay. सारे functional groups नहीं दिखा सकते हैं tautomerism. खाली वो functional groups जिसमें pi bond होना चाहिए और दो एटम्स ऑफ डिफरेंट इलेक्ट्रोनेगेटिविटीज के बीच में पाई बॉन्ड होना चाहिए और अल्फा हाइड्रोजन उसका एसिडिक होना चाहिए, तब जाके टॉटोमेरिज्म होता है. So there are only few functional groups which show tautomerism. I'll be doing all those, of course. Write down the enol form for this. Write down their enolic form. Vedant, does the fourth compound have alpha hydrogen? So how will it form enol? It cannot, correct? अभिमन्यु थर्ड हैज बच्चे, थर्ड में है अल्फा हाइड्रोजन. All of you finished? You can write the double bond right side or left side. It's the same thing. Okay. This won't show any tautomerism. No enol form for this because it doesn't have alpha hydrogen here. Did you get this? You can also show it like this. इसका ये फॉर्म ज्यादा स्टेबल होगा इससे. Why would this form be more stable? Because जब इसमें रेजोनेंस होगा तब कौन से एटम पे नेगेटिव चार्ज जाएगा? Which atom will have the negative charge on resonance? Yes, oxygen. इसमें जब रेजोनेंस होगा तब कार्बन पे नेगेटिव होगा. Anyway, C double bond O. C double bond O is more stable than C double bond C. इसका bond energy is higher. So C double bond O is more stable than, yes, keto form is more stable than enol. But there are conditions where enol form also predominates. Okay. Did you get this one for the last one? Okay. Can I say this becomes aromatic? Okay. Fine. So all of you got these? Now just write down a statement which I am giving.
Ma'am, can you show the last slide?
Yeah.
Yes, Tapna.
Now just write down a statement which I'm giving. The keto form usually predominates. The keto form usually predominates over the enol. Keto form usually predominates over the enol. This is because the C double bond, C double bond O bond energy, the C double bond O bond energy is higher. The C double bond O bond energy is higher than C double bond. The C double bond O bond energy is higher than C double bond C. Last का जो enol form है, that is named as what? That is named as benzene 1,3,5 triol. Na? Benzene 1,3,5 triol, also known as fluoroglucinol. Okay, I think Disha has given it in the chat box. You can refer to it again. Last one, what you want? Om, I didn't get. Last का क्या चाहिए आपको? वो दिशा ने लिखा है पूरा ऊपर चैट बॉक्स में. You want me to show? मतलब ये कैसे हुआ लास्ट वाला? Om, I'm asking you, बच्चा. ये कैसे हुआ? इसमें कैसे कन्वर्ट हुआ? You want me to do that and show it to you? Okay, I think I don't know. He's not replying. Fine. Okay. Now, as I've said that keto form usually predominates over the enol form because keto form, the bond energy is higher than C double bond C. C double bond O bond energy is higher than C double bond C. That means अगर ये compound लिया मैंने तो इसमें keto form as much as more than 98% होगा और enol form will be almost less than 2% because C double bond C bond energy is lower than C double bond O. But इसमें थोड़ा enol ज्यादा होगा. इसमें enol ज्यादा क्यों होगा? Because इसका enol aromatic है. Correct? इसका enol aromatic है तो इसमें enol content थोड़ा ज्यादा होगा. But इसमें keto content ज्यादा होगा. Because C double bond O is more stable than C double bond C. So now I'll give you the conditions which favor the higher enol content. Just write down conditions favoring higher enol content. Okay, aromatic nature of the enol form. एक एग्जाम्पल तो मैं दे चुकी हूँ, ये वाला इनॉल एरोमेटिक है, इसलिए इनॉल कंटेंट ज्यादा होगा इसमें. अब ये ले सकते हैं. इसका मैंने अगर इनॉल बनाया so it will prefer going in this form. Okay. अब ये जो है ये पाई बॉन्ड हमेशा इधर ही रहेगा by resonance. Can I classify this as an aromatic system? This is that cycloheptatrienyl cation, the tropylium ion. So this also enol content. Enol will be higher than keto. So enol form will predominate over keto because enol is aromatic. Did you understand how I got it? ये अल्फा कार्बन है, ये अल्फा हाइड्रोजन है, ये यहाँ शिफ्ट होगा, H प्लस निकलेगा, ये यहाँ शिफ्ट होगा, ये यहाँ शिफ्ट होगा और ये H इधर माइग्रेट करेगा. सो इनॉल कंटेंट ज्यादा होता है जब सिस्टम एरोमेटिक हो जाता है. इसका इनॉल क्या होगा? Can I say I get the formation of naphthalene ring here? तो ये भी aromatic हो गया. So here also the enol content will dominate over the keto form. This example all of you have understood? हाँ, यहाँ से ये H माइग्रेट करेगा, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा, H प्लस बाहर आएगा, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा और ये यहाँ शिफ्ट होगा. That is how you get the enol. Okay. Okay. Now I've got a good question here. Abhimanyu says that what happened if I take the sp2 hybrid carbon as the alpha carbon? Would enolization occur like this? I'll show it to you. अगर ये H आप निकालते हो, पहले तो ये H एसिडिक नहीं है, फिर भी अगर ये H आप निकालते हो, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा, ये यहाँ शिफ्ट होगा, H माइग्रेट करेगा, तो आपका स्ट्रक्चर कैसा आ जाएगा? ये OH हो जाएगा, यहाँ पर आपको डबल बॉन्ड आ जाएगा. This carbon will have to attain what hybridization? SP. SP hybridization will not be possible in the 7-membered ring. Minimum carbon needed for that linear geometry. SP hybridization मतलब linear geometry. So minimum carbon required there will be 8. तो यहाँ पर possible नहीं होगा. You cannot have this either be double bond or either be double bond. Okay. So this is not possible. Did you understand, Abhimanyu? Okay. So I think first point, aromatic nature of enol form. I think this you have understood. Going to the second one. Next is presence of conjugation in the enol form. Now, what do I mean by that? Say, for example, I take this compound. If I try to write the enol form for this, what will happen? यहाँ से H निकलेगा और यहाँ migrate करेगा, alpha hydrogen. I'll show it to you कैसे हुआ है ये. H plus comes out. This electron pair shifts here. This shifts here and this migrates. So I get this enol. Can I say this enol is more conjugated than the keto form? Conjugation कैसा है? देखो resonance यहाँ से चालू होगा, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट होगा, ये यहाँ शिफ्ट होगा, ये यहाँ शिफ्ट होगा. So complete delocalized system यहाँ से यहाँ तक है वो. So here also enol content will be higher than keto because of conjugation in the molecule. Conjugation मतलब resonance ज्यादा है, इसमें resonance ज्यादा है as compared to this. इसमें resonance सिर्फ बेंजीन रिंग में है, बट इसमें resonance यहाँ ऑक्सीजन से चालू हो रहा है और बेंजीन में कैरिड फॉरवर्ड हो रहा है. Next is H bonding. in the enol form? Now this compound is a beta diketone. Have I told you earlier what are beta diketones? What's a beta diketone?
And when the ketonic group is on the beta carbon, it is called beta diketone.
Yes. Now, this is ketone. This is the alpha carbon. The other keto group is on the beta carbon with respect to this. Same way this ketone. This is the alpha carbon. The other keto group is on the beta carbon with respect to that. That is why it is called as a beta diketone. Could you identify the acidic hydrogen? This is the alpha carbon. This is also the alpha carbon, and this is also the alpha carbon. इसमें से which will have the most acidic hydrogen? This one or this one? इसका और इसका acidic strength तो same होगा. हाँ, the middle one. Why the middle one will be more acidic? Because if you remove this H, the negative charge on carbon can be resonance stabilized on either side. This side also, and this side also. So that makes this alpha hydrogen acidic. So migration will take place for that alpha hydrogen. It will migrate to one of the ketonic groups. Both are same, so it can migrate anywhere, either on either of the sides. So जैसे ये migrate करेगा, देखो ये H है. Wait, I'll show it. This is alpha carbon. Okay. This electron pair will shift here. H plus will come out. This moves here, and the H migrates there. So I'll get CH3, C, OH, double bond, CH, C double bond O, CH3. Okay. Now this compound, there is stabilization due to H bonding, intramolecular hydrogen bonding. Conjugated भी है molecule. Conjugated कैसे है? ये lone pair यहाँ shift हो सकता है resonance से, ये यहाँ पर और ये यहाँ पर. So molecule is conjugated also, and it has intramolecular hydrogen bonding also. So here also the enol form is more stable than the ketone. So this will most मतलब predominantly occur in this form. इसका percentage ज़्यादा होगा as compared to this. तो इसका predominance ज़्यादा होगा because this form is more stable. Enol is more stable because it is a conjugated system as well as it is stabilized by intramolecular hydrogen bonding. Abhimanyu, what type of resonance for the end methyl groups? Resonance means you are talking about the pi electron transfer. Methyl group में pi electrons कहाँ आ रहे हैं? Methyl और electron withdrawing नहीं, electron donating groups होते हैं methyl. Plus I effect होगा उनका. Did you finish writing? Any questions still here? Any questions, any doubts in the mind? Okay, so I'm proceeding. इसका भी अगर लिखोगे आप, इसका इनॉल क्या होगा? इसका इनॉल also is stabilized by intramolecular hydrogen bonding. Okay, now next you write down. Presence of steric hindrance on the alpha carbon increases the enol content. Now let me explain what I mean by this. Okay. Now this is the alpha carbon. ये aldehyde group है. ये alpha carbon है. The alpha carbon you can see is sterically hindered because of these bulky groups. This is a tertiary butyl group and this is the isopropyl group. Now this prefers the enol form and I'll tell you the reason also behind that. ये H plus निकलेगा, ये यहाँ पर pi bond बनेगा, ये यहाँ migrate करेगा. Okay. Now why would this prefer the enol over the keto form? Disha, tertiary butyl group is the bulkiest group. When you have lots of branching increases the steric repulsions. Okay, इनके बीच में repulsion ज़्यादा होंगे ना, because these groups come very close to each other. So the van der Waals repulsive forces increase when branching increases. This is a highly branched alkyl group, so it has maximum steric hindrance. Okay. Yes, what you said is correct. The hydrogen moves away and creates space. Very good. The carbon here is what hybridized, the alpha carbon. Alpha carbon is what hybridized? Yes, sp3. When the enol is formed, the hybridization changes into what for the alpha carbon? Yes, it changes into sp2. The bond angle between these groups here was 109 degree 28 minutes because of the tetrahedral nature of the carbon. And now the bond angle between these bulky groups has become 120. So can I increased? And since the
Which
angles have
might
increased,
really-
they have become further away from each other. So their repulsive forces become smaller. In other words, here the enol will be more stable than the keto form. So that would increase the enol content. Did you all finish writing this? Is this done? Okay. कुछ भी डाउट आ रहा है तो पूछ लेना जरा. Okay. Aisha, one more example means just you can show any bulky groups here, ना branching वाले, उसका इनॉल कंटेंट ज्यादा होगा, क्योंकि फिर हाइब्रिडाइजेशन जब चेंज हो जाएगा sp3 से sp2, बॉन्ड एंगल यहाँ पे बढ़ जाएगा, 120 का हो जाएगा, और बॉन्ड एंगल बढ़ गया मतलब ग्रुप्स दूर जा रहे हैं तो उनके बीच के रिपल्सिव फोर्सेस कम हो जाएंगे. एनी बल्की ग्रुप यू कैन शो हियर. Okay. Then presence of electron withdrawing groups. You can write as electron withdrawing groups as EWG. Electron withdrawing groups increases the enol content. While electron donating groups decrease the enol content. Now what do I mean by this? Simply let me take acetaldehyde and acetone. Difference between these two lies in one methyl group. इसमें एक मिथाइल एक्स्ट्रा है, इसमें हाइड्रोजन है. मिथाइल का प्लस आई इफेक्ट आता है, मतलब ये डोनेट करता है इलेक्ट्रॉन्स. इफ इट डोनेट्स इलेक्ट्रॉन्स, and if I'm talking about the acidic nature of this alpha hydrogen, which will be more acidic, this one or this one? Is this more acidic or is this more acidic? This has plus I effect of the other methyl. So now tell me which will be more acidic. Yes, the first one. And if the first one is more acidic, iska enol content will be slightly more than the enol content of the second one. क्योंकि acidic strength कम कर देता है. Electron donating group अगर होता है, so it reduces the acidic strength. And if it reduces the acidic strength, it will reduce prototropy. Means enolization will not occur easily. Okay. So first one being more acidic, the enol here will be more than the enol content here. Of course इन दोनों में कंपेयर करेंगे तो कीटो फॉर्म ज्यादा होगा इनॉल से, बिकॉज इसमें इनॉल स्टेबल नहीं है ज्यादा. इनॉल ना हाइड्रोजन बॉन्डिंग से स्टेबलाइज हो रहा है, ना कॉन्जुगेशन है, ना कुछ है इसमें, तो इसका कीटो फॉर्म ज्यादा डोमिनेंट है. मगर अगर इसका कीटो फॉर्म 98% है और इसका इनॉल फॉर्म अगर 2% है, तो इसका कीटो फॉर्म 98.5% के आसपास होगा और इनॉल 1.5% के पास आसपास होगा. मतलब इसका इनॉल का परसेंटेज इससे कम है. And the reason behind that is the presence of this electron donating group. Now I've given you these three compounds. You have a beta ketoaldehyde, then you have a beta diketone, and you have a beta ketoester. ये एस्टर है, ये अल्फा कार्बन है और उसके बीटा कार्बन पे कीटोन है, सो बीटा कीटोएस्टर. ये एल्डिहाइड है, ये उसका अल्फा कार्बन है, बीटा कार्बन पे कीटोन है, सो बीटा कीटोएल्डिहाइड. ये तो आपको पता है. इनमें से सबसे ज्यादा इनॉल कंटेंट किसमें होगा? देखो सब में एसिडिक हाइड्रोजन तो ये वाला है, बीच वाला, तो ये इधर माइग्रेट करेगा कीटोन पे और वो स्टेबलाइज होगा एच बॉन्डिंग से सबका. बट माय क्वेश्चन टू यू इज which will have maximum enol content? Disha says it is going to be beta keto ester. What about the others? Any different views? The only thing now you have to compare is this. The difference lies here. Vedant, could you tell me why is the first one having higher enol content? Okay, because it has a hydrogen. What if I want to compare between beta diketone and beta keto ester? Okay, why would diketone be having more enol content than beta keto ester, Ojas? Very good. Yes. Okay. So the order of enolization is this. Okay. Highest enol content इसमें होगा because इसमें H है. इसमें प्लस आई इफेक्ट आ गया, और अगर प्लस आई इफेक्ट आ गया तो क्या हो जाएगा? इसका एसिडिक स्ट्रेंथ थोड़ा कम हो जाएगा, तो इनोलाइजेशन कम होगा. इसका एसिडिक स्ट्रेंथ और भी कम हो जाएगा बिकॉज दिस शोज प्लस आर इफेक्ट फ्रॉम हियर. ये रेजोनेंस से देता है इलेक्ट्रॉन्स, तो इसका जो कॉन्जुगेट बेस बनेगा H प्लस निकलने के बाद, उसका रेजोनेंस थोड़ा कम हो जाएगा. दैट मेक्स दिस लेस एसिडिक, एंड इफ दिस इज लेस एसिडिक, इसका इनॉल कंटेंट कम होगा. डिड यू अंडरस्टैंड दिस? इसमें ऑक्सीजन का प्लस आर इफेक्ट आएगा. Okay, so beta keto aldehyde here will have a higher enol content than beta diketones, which again will have a higher enol content than beta keto ester. Did all of you understand here? Okay, Disha, what about you?
Ma'am, beta aldehyde only.
हाँ, you got, अभी समझा है क्यों?
Yes, ma'am.
Okay. Okay, did you all finish writing this? This is decreasing enol content. Now the last point I'm going to do for conditions favoring higher enol content. Or did you all finish writing this? Can I proceed? Okay. Okay, now presence of aprotic solvents increases the enol content. What do you mean by protic solvent and aprotic solvent? I have done it earlier. Protic solvent and aprotic solvent. What's the difference? Uh, Not polar and non-polar. Yes, Aisha, very good. Protic solvents are those which are capable of forming hydrogen bonds with the solute particles or solute molecules. So protic solvents are those which can form hydrogen bonds with the solute molecules, and aprotic are those which cannot form hydrogen bonds with the solute. Okay, I repeat, protic solvents are those which are capable of forming hydrogen bonds with the solute molecules, and aprotic solvents cannot form any hydrogen bonds. Aprotic are further classified into polar and non-polar. Haven't I done this earlier? Okay. Now a keto form. Can I say between two acetone molecules? The intermolecular attractions will be very small. In fact, only van der Waals attractions. Correct? So between two molecules of keto form here, the force of attraction is only van der Waals. But when I place this in a protic solvent like water, water stabilizes the keto form by forming intermolecular hydrogen bonds. तो ये intermolecular hydrogen bonds की वजह से इनके बीच में attractive forces बढ़ जाते हैं, and therefore the keto form will predominate or will be present in more amounts in protic solvent like water, because water stabilizes the ketonic group by forming hydrogen bonds with the ketonic group. ये part समझ में आया है? Okay. Enol form doesn't require any such stabilization, because in enol form the molecules, the enolic compounds themselves can undergo the formation of intermolecular hydrogen bonds. So they are stabilized by themselves using intermolecular hydrogen bonds. तो अगर protic solvent है तो this form will predominate. But अगर aprotic है तो this form will predominate. Because aprotic में ये stable नहीं हो पाता है. So it changes into this form. Are you understanding? aprotic में ये form ज़्यादा stable नहीं होता है because इनके बीच में attractive forces कम हो जाते हैं. अगर aprotic solvent है, it will try to go into enol form. अगर protic solvent है, so it will stabilize by hydrogen bonding, and then keto group is more stable than C double bond C. That is why keto form predominates. It is also stabilized by H bonding in protic solvents. Okay. तो अगर मैंने acetone लिया protic solvent में, तो ये almost 99.9% form होगा keto form, and this will be less than 0.1%. मगर यही चीज अगर मैंने कार्बन टेट्राक्लोराइड में लिया या क्लोरोफॉर्म में लिया या किसी व्हाट यू से एप्रोटिक सॉल्वेंट लाइक ईथर या किसी और में लिया, तो उसमें ये इनॉल फॉर्म स्टेबलाइज हो जाएगा, बिकॉज इनॉल फॉर्म स्टेबलाइजेस इटसेल्फ बाय फॉर्मिंग हाइड्रोजन बॉन्ड्स लाइक दिस. सो दिस फॉर्म इज मोर प्रेडोमिनेंट इन aprotic solvent, and this form will be predominant in protic solvents. So these were the conditions which favor a higher enol content over the keto form. अगर इनमें से कोई भी condition नहीं है, then remember the keto form will always be the predominant form. Okay. If there is no such condition present, then always the keto form will be present in higher amounts as compared to the enol, because of the high C double bond O bond energy, as compared to C double bond C. Did you all finish writing this? Abhimanyu, as you take the solvent, वैसे तो कीटो फॉर्म हमेशा ज्यादा रहता है, मगर सॉल्वेंट अगर प्योर आप ए प्रोटिक ले लेते हो तो इनॉल का कंटेंट, जैसे अगर ये कंपाउंड लिया मैंने, ये कंपाउंड में इनॉल कंटेंट ज्यादा होता है ना कीटो से, बिकॉज इसमें हाइड्रोजन बॉन्डिंग भी होता है और कॉन्जुगेशन भी आता है। जैसे जैसे कॉन्जुगेशन बढ़ाते जाओगे, जैसे अगर मैंने ये कंपाउंड लिया, वेट, अब क्या होगा देखो, ये इलेक्ट्रॉन विड्रॉइंग ग्रुप भी है, जिसकी वजह से एसिडिक स्ट्रेंथ बढ़ जाएगा इसका, और जब ये इनॉल में जाएगा तो इसका कॉन्जुगेशन भी बहुत ज्यादा हो जाएगा। सॉरी, तो इसका इनॉल विल प्रिडोमिनेट ओवर द कीटो फॉर्म। डिड यू अंडरस्टैंड दिस? इसका इनॉल विल प्रिडोमिनेट बिकॉज कॉन्जुगेशन देखो कहां तक है, ये पूरा वहां से वहां तक कॉन्जुगेशन है। पाई बॉन्ड्स कैन व्हाट यू से रेजोनेट, पूरे बेंजीन के पाई इलेक्ट्रॉन्स, ये पाई इलेक्ट्रॉन, ये पाई इलेक्ट्रॉन, सब में रेजोनेंस है इधर। और इसमें रेजोनेंस ऐसे भी दिखा सकते हो, ये प्लस होता है और ये माइनस, तो इसका रेजोनेंस ऐसे भी हो सकता है। यहाँ पर भी है, ऑफ कोर्स यहाँ तो है ही, बट उसके साथ साथ यहाँ पर भी रेजोनेंस है मॉलिक्यूल। ओके, तो कॉन्जुगेशन बहुत ज्यादा है मॉलिक्यूल में, तो इसका इनॉल विल प्रिडोमिनेट ओवर द कीटो फॉर्म। और अगर इसको आपने ए प्रोटिक में ले लिया तो इसका कंटेंट इतना ज्यादा बढ़ जाता है कि ये ऑलमोस्ट नेग्लिजिबल हो जाता है ये फॉर्म। इसमें आप एच बॉन्डिंग से भी स्टेबलाइज कर पाओगे। एच बॉन्डिंग कैसे बनेगा इसमें? ये देखो, इसमें हाइड्रोजन बॉन्डिंग भी है, कॉन्जुगेशन भी है, और ये हाइड्रोजन बहुत ज्यादा एसिडिक भी हो गया है। एसिडिक क्यों हो गया है? क्योंकि वो नाइट्रो ग्रुप वहां पे प्रेजेंट है। तो इसका इनॉल विल बी मोर देन द कीटो फॉर्म हियर, या OH है नाइट्रो ग्रुप, यहाँ पर एच बॉन्डिंग होगा ना इनका। Till here, all of you have understood?
Yes, ma'am.
कुछ भी डाउट है यहाँ तक?
यहाँ पे CCl4 लिखा है ना सर्कल में?
हाँ, CCl4 या ईथर। Can I proceed? Have you finished writing this? Okay. Write down their enol forms. Please try out the exercise 1 now. Okay? Pura exercise 1. Anyway, I'll be discussing the entire exercise in the next class also. Next class, I'll be covering that entire. Yes, Abhimanyu, very good. Okay. इसमें तो ये हाइड्रोजन माइग्रेट करेगा. You'll get the formation of phenol. जो aromatic है, तो इसका enol content will be higher than keto form because ये aromatic है. अब इसमें would you take this hydrogen? Is this hydrogen acidic? इसका कौन सा हाइड्रोजन एसिडिक है? ये वाला एसिडिक है, नॉट दिस वन. दिस विल कम आउट एज H+. जैसे ही H+ निकलेगा, ये इलेक्ट्रॉन पेयर यहां शिफ्ट होगा टू फॉर्म अ डबल बॉन्ड. पर ये कार्बन 5 बॉन्ड तो नहीं बना सकता है ना. तो जैसे ही इलेक्ट्रॉन पेयर अंदर शिफ्ट होगा, साइमल्टेनियसली दिस विल मूव हियर, which will cause the simultaneous shift of this electron pair. Oxygen will develop a negative charge and this H will then migrate there. So just see what I'm going to get. यहाँ से H निकला, इलेक्ट्रॉन पेयर यहाँ शिफ्ट हुआ, ये इलेक्ट्रॉन पेयर यहाँ शिफ्ट हुआ, ये इलेक्ट्रॉन पेयर ऑक्सीजन पे शिफ्ट हुआ, और इसका H यहाँ माइग्रेट हुआ, तो ये कंपाउंड भी आपको फिनॉल ही बनेगा। ओके, दिस हाइड्रोजन इज एसिडिक, नॉट दीज वंस। इसमें तो नो टॉटोमेरिज्म। व्हाई नो टॉटोमेरिज्म? Abhimanyu, you have said no tautomerism, but what is the reason for that? Because this H will not be able to migrate. Why it will not be able to migrate? Any of the H here, अगर इधर migrate करेगा तो यहाँ पे एक ही कार्बन पे दो डबल बॉन्ड्स आ जाएंगे. Carbon will have to become sp hybridized, correct? Which cannot be attained in a 6-membered ring. So no tautomerism in the last one. ये जो सिस्टम है इसको ट्रायड सिस्टम बोलते हैं. This system is called as a pentad system. अब इसको ट्रायड क्यों बोलते हैं, इसको पेंटाड क्यों बोलते हैं? Let me explain. Okay, pay attention now. The H is migrating from carbon to oxygen. This is the first atom, carbon. First atom, ये second atom, ये third atom है. So it is going from the first atom, that is carbon, to the third atom, that is oxygen. That is why this is called as a triad system. Pay attention here also. H is migrating from this carbon to that oxygen. This is the first atom, second atom, third atom, fourth atom, fifth atom. So it is going from first atom to the fifth atom. That is why it is called as a pentad system. Did you understand why triad and why pentad? Okay. What about the tautomerism occurring here? Could you write the tautomer for this? Yes, this is a dyad system. Very good. इसका tautomer क्या होगा? ये H plus निकलेगा. That H plus will go and attack the lone pair on nitrogen. ये इलेक्ट्रॉन पेयर कार्बन पे शिफ्ट हो जाएगा. नाइट्रोजन अपना लोन पेयर उस H plus के साथ शेयर करेगा, जिसकी वजह से फॉर्मल चार्ज आएगा. गिव मी द फॉर्मल चार्जेस ऑन कार्बन एंड नाइट्रोजन.
minus plus.
What is plus?
Carbon will get negative and nitrogen will get positive.
These are the formal charges. Now these two are tautomers because it is a migration of a proton from carbon to nitrogen and vice versa. These two are tautomers and this is a dyad system. Why dyad system? Because H is migrating from the first atom to its second atom. So it's a dyad system. Now I have to do ring chain tautomerism, which I'll be starting in the next class only. Abhi time nahi hai, only 4 minutes are there. Ring chain tautomerism is remaining. And even you have tautomerism in other functional groups. And then you have the mechanism, that is acid catalyzed tautomerism and base catalyzed tautomerism. So these are the topics remaining, which I'll be covering it in the next class. So next class also I'll continue with tautomerism only. Acid catalyzed and base catalyzed tautomerism. So these are the parts still remaining, which I'll be taking it in the next class. Next class, I will complete tautomerism and I'll be solving the booklet first exercise with you all. Fine. Okay. वेदांत होमवर्क वही है, एक्सरसाइज 1 पूरा कंप्लीट करो. टॉटोमेरिज्म के क्वेश्चंस भी ट्राई कर लेना आप, ठीक है? ओके. Try out as many as you can get. Okay. Chalo, bye all of you. Yeah.